In network analysis, it's extremely important to understand how traffic flows through various network devices. We'll begin by looking at how network traffic flows through switches. And then in the next section, we'll look at how that traffic flows through routers. Now, unlike in a switched environment, when we look at a routed environment, we will see some definite changes to the traffic after it flows through a router. In the section after that, we will look at how proxy devices, firewalls, and port address translation or network address translation devices affect the traffic flows. Let's review basic switch functionality first. Now, a basic switch is a layer 2 device, and when we talk about layer 2, we're talking about the OSI model. Layer 2 is the data link layer, and switches forward based on hardware addresses that reside at the layer 2 of the OSI model. So they're forwarding only based on hardware addresses, or MAC addresses, media access control addresses. If a broadcast is sent up to a switch, that switch is going to forward that broadcast out all ports. This is true for multicasts as well by default. In addition, if a packet comes to a switch and the switch doesn't recognize the target MAC address, so maybe you handcraft a packet and you send it up to hardware address 666666, 666666, that switch will look in its forwarding tables to see if it knows the MAC address. And if it doesn't know the MAC address, it will treat it just like a broadcast or multicast. It will send it out all ports hoping to discover a target that uses that MAC address. Now, routers are completely different because routers are layer 3 devices, and they do not forward broadcasts. They might be configured to forward multicasts, however. And if traffic comes into an unknown MAC address, it drops the packet because it expects packets addressed to the router itself. So let's begin by looking at how switches handle traffic. We'll start with this very simple network diagram. Over here we have a client, and this client connects to one of the switch ports, and from the switch port we connect out to a web server. This is all one network. So let's take a look at how the traffic will be affected. First, look at our client's IP address. The client's IP address is 10.0.0.1. And as packets flow from our client to this server, they flow down through the network interface card driver and then through the network interface card itself. The source address that's placed on the packet will be the source MAC address, media access control, or hardware address of our client. If our client wants to talk to this server, the client is going to have to address the packet to hardware address D. In addition, inside the TCP/IP stack, the client will address the packet to 10.0.0.2. So we have two addresses inside of our packets, or should I say two sets of addresses. Switches forward traffic based on the MAC address information. Switches do not forward traffic based on IP addresses. If you have a switch that does forward traffic based on IP addresses, it's acting as a router. Down here, this area is considered layer 2, the data link layer on the OSI model. Above that is layer 3, the network layer of the OSI model. Switches are layer 2 devices. So let's take a look at how a switch behaves when packets arrive. The packets are sent out from the client onto the cabling system. In this case, the packets will go from MAC address A, the client's MAC address, and from IP address 10.0.0.1. The packet would be addressed to MAC address D, and I'm just using short MAC addresses here. A standard Ethernet address would be 6 bytes long. We'd see those 6 bytes separated by colons, but just to make it easier for the diagram, I'm just assigning them a symbolic letter. These packets would be sent directly to port 1 of the switch. Upon receipt of these packets, the switch will perform error checking on the packets. If the switch detects that there's a MAC layer error on the packets, in other words, the Ethernet frame check sequence value is invalid, the switch will discard the packet. It won't forward that packet. The switch then will look in its MAC address tables to see what port MAC address D resides on. And then the switch will forward the packet accordingly. When we take a look at the packet as it's gone out of the switch port 2, we can see that the addressing has not changed at all. It still appears to be from MAC address A and IP address 10.0.0.1, and it's going to MAC address D at IP address 10.0.0.2, and this traffic will flow up to the web server. So when we look at switched traffic on a network analyzer, we can't tell if it's gone through switches or not, because switches should never affect hardware address information or the network address information. Switches are considered transparent. Now, this is basic switching functionality. There are a lot of switches out there today that add on functionality to create a layer 3 switch, which is a device that will switch when it can but route when it must. I'd like to show you what switched traffic looks like when we've captured a packet on each side of a switch. I have 2 instances of Wireshark running, and I've just basically separated them out by just a little bit of space here. On the top, I'm looking at a trace file called switch-side-a.pcapng, and on the bottom, I'm looking at a trace file called switch-side-b.pcapng. Let's begin with the Ethernet header. Before the packet went through the switch, we have an Ethernet header that ends in a 436F. And the destination hardware address is one that ends in E2B9. We'll just use the last couple of numbers for convenience. After the packet has gone through the switch, we can see that we have the same 436F in the source hardware address and the same E2B9 in the destination hardware address field. When we look at the IP header, there's also no change caused by going through the switch. We can see the packet comes from 192.168.1.71. The destination is 161.69.12.13, and down below we have the exact same information. Can we tell this packet has gone through a switch down here? No, we can't. As I mentioned before, switches should be completely transparent. Now let's go take a look at how routers will affect the network traffic.